In this lecture, we will cover types of statistics, research, variables, and scales of measurement. When we have a clinical question, it's obvious that we can't find the answer by measuring the entire population. A parameter is an unknown value that represents the data that we would collect for an entire population. And since we can't measure them, we have to estimate it using a smaller sample representative of the larger group. A parameter doesn't vary, but each sample drawn from the larger population will have its own value of any statistic that is used to estimate the parameter. This is important to know. Parameters are assigned Greek letters, and statistics from the sample are assigned Roman letters. You see here population mean, or mu, versus x bar, which is the sample mean. This is what you will collect and measure when you do a research project. In computing and reporting a statistic, as I said, Greek letters represent the population data and Roman letters represent the sample data. I think you'll find the information on this slide helpful when you begin to look at the various equations that are represented in your book. Statistics is the collection, organization, and interpretation of data. A single statistic is a quantity that is calculated from a sample of data. Statistics is used to describe, summarize data, identify associations and relationships, and even to make predictions or generalizations to the larger population. Stats is divided into two broad categories. Descriptive statistics tells you characteristics of your sample or population. Every study that's done will always describe the group or the sample that has been measured. That way you'll know if a published study sample represents the group that you want to study. Inferential statistics are values that infer the results of a sample to the whole population from which the sample is drawn. Data is defined as factual information expressed by numbers, numeric variables, or narrative form, and those are called string variables. Qualitative research uses the narrative or string variables. This data is collected from interviews of individuals and groups using open-ended questions regarding feelings, attitudes, and behaviors. Quantitative research utilizes data gathered in numeric form. We get this from experiments, surveys, correlations, and meta-analysis. Variables are defined as a characteristic being measured that varies among individuals, events, or objects. So basically, a variable is an attribute that describes a person, place, thing, idea, or observation. The value of any variable can vary from one entity to another. When we conduct a study that looks at only one variable, we say that we're working with univariate data. Suppose, for example, that we conducted a survey to estimate the average weight of high school students. Since we're only working with one variable, weight, we would be working with univariate data. In this case, data would be reported as mean, mode, and frequency distribution. Bivariate data. When we conduct a study that examines the relationship between two variables, we're working with bivariate data. Suppose we conducted a study to see if there was a relationship between the height and weight of high school students. Since we're working with two variables, height and weight, we'd be working with bivariate data. So in univariate analysis, we want to know the basic characteristics of one variable of interest. We use this type of analysis to check data samples when we're looking for outliers, to find errors, to examine the variability in a single sample, to describe the sample for a single characteristic, and to verify the assumptions that are associated with a particular inferential statistical test that we want to use. In bivariate analysis, more than one variable at a time is handled. It allows for the use of more robust statistical methods like ANOVA and regression. When we conduct bivariate analysis, we have to make sure that we have met certain assumptions, such as a normal sample and equal variability between the groups being compared, if there is a comparison group. Variables are classified in a study as independent or dependent. You will need to learn how to label a variable as an IV or a DV. The independent variable is the one that the researcher is manipulating. It's also known as the effect, and some studies may have more than one independent variable. The dependent variable is the outcome that the researcher measures. Studies may have more than one dependent variable. A good way to think of this is that the dependent variable depends on the independent variable, which doesn't change. So here's an example. If we want to know if infant formula affects growth velocity in babies, the infant formula would be independent variable, but the growth velocity is the dependent variable. In our question, we want to know if growth velocity depends on the type of infant formula that we feed a baby. Another example, the type of NCLEX review guide and NCLEX score. The question is, does the type of review influence the score on the NCLEX? The NCLEX score is dependent on the review guide. Quantitative variables can be further classified as discrete or continuous. Some people call it non-continuous. If a variable can take on any value between its minimum value and its maximum value, it's called a continuous variable. Otherwise, it's called a discrete, non-continuous, or categorical variable. Nominal level data, number of patients on hospital floors, number of languages a person speaks, number of people sleeping in a stats class, gender, race, blood types. These are non-continuous discrete variables. Basically, there are no relationships between each variable. When nominal outcome variables are used, non-parametric statistical tests like chi-square and correlation and descriptive stats will be used to report your results. These statistical tests are weak and limit the interpretation of your results. Descriptive statistics are limited to number, percent, and mode when we use categorical data. There's no mean, median, range, or standard deviation. After all, how can you report a mean gender? You're either male or female. How can you report mean or average race? Race, gender, geographic location, religion, diagnoses, these are all categorical. Chi-square can be used to check for differences between groups when we're looking at categorical data. Let's say that we want to know if a ketogenic diet is effective in reducing seizures. We could measure it this way. Begin the diet and ask the parents a yes or no question. Did your child have less seizures while on the ketogenic diet? Parents could report yes or no. However, nominal level data like this limits our interpretation of results. Yes or no answers really don't tell us much. Even if there are more yeses than nos, we don't know if they had a 2% reduction in seizures or a 92% reduction in seizure activity. For some data, all we have are yes and no type of responses that we can measure. But whenever possible, it's better to move from nominal level up the scale a little bit. Here are some examples of continuous variables. Height, blood sugar, blood pressure, minutes required on a dialysis machine. Quantitative variables assigned to each level of measurement, and each level has set characteristics. Lower level of measurement limits the statistical tests that can be used to interpret and display data, as we just gave you an example. Moving up that level allows for more robust tests and greater precision in analyzing and interpreting our data. So whenever possible, select variables that represent a higher level. Our first level is nominal. Again, it's categorical or non-continuous data. Moving up, the next one is ordinal. Data are placed into a rank order. We can provide a relationship between data points. However, there are imprecise distances between those ranks. We don't know the exact relationship. Examples are level of education, grade in school, or dress size. We can use a few more statistics to describe the data, such as median or average, mode, percentile rank. We can use correlation and non-parametric analysis of variance to interpret and report results. Let's use our previous example. Let's say that we, again, found a group of parents who had children with seizures. We placed their children on a ketogenic diet. Rather than asking them, did your child experience less seizures while on the ketogenic diet, we could employ the use of a Likert scale. While on the ketogenic diet, my child had less seizure activity. We could say strongly agree, somewhat, or do not agree. Again, our conclusions are limited, but it's a little better than yes and no answers. This type of data is best displayed using bar charts or pie charts, as is nominal data if you have more than one category. The distance between data points in interval and ratio has meaning. We can use stronger parametric tests like t-test, ANOVA, MANOVA, regression, and correlation. Our interpretation is more robust and reliable. So whenever possible, select interval ratio level variables. Interval and ratio level data are treated the same in most statistical tests. This data is represented as measures of central tendency in descriptive statistics. Mean, median, mode, range, standard deviation, and z-scores are used to report results. Descriptive statistics use things like histograms, scatter plots, interquartile range to display the data. All statistics may be used for ratio level data, and most can be used for interval level. An example here, again going back to our ketogenic diet. Let's say that we had a validated seizure activity tool and that we had independent researchers go in, place children on a ketogenic diet, and then record all seizure activity during an established time frame. Or perhaps we could have the children hooked up to some sort of an electronic device that would control brain activity for a set period of time. Now we have a potential true zero of absolute no seizure activity all the way to infinity for seizures that might also capture how long the seizure lasted, the intensity and type of seizure. We can use more robust statistical tests to measure the effect of the diet. We can compare the mean number of seizures before and after the diet and determine significance. If ketone production is measured, which is generally what happens while you're on the ketogenic diet, We might be able to conduct a correlation and regression analysis to see if higher ketone production is associated with less seizure intensity. We might be able to show that even if the number of seizures didn't decline, the time or intensity or type of seizure was reduced by the ketotic state. And so you see the value and the benefit of selecting interval and ratio level data whenever possible. Properly selecting and identifying variables of interest in a study is crucial when you select the appropriate statistic and enter that data into SPSS. Let's say you want to know the effect of a weight loss program on anthropometrics in elementary school children. The most practical field methods to measure anthropometrics in kids include BMI, skin folds, and a new machine called a bioelectrical impedance. Tanita scale produces a nice one that's appropriate for children. We must first select all the variables that we will measure so we'll know what type of data to collect before and after the weight loss program. It's important to collect descriptive data too, so that if you publish your results and someone else reads your study, they'll want to know something about the sample size and their characteristics that you measured. All of this information should be entered into a code book. Code books help you think about your study and organize how you carry it out. Developing and editing a code book for variables of interest in a study will help you think about all that you need to collect, how to code it and handle it. This is very important when you begin to interpret your SPSS outputs. It will also help you identify how your variables will be entered into SPSS. Remember, when we enter numeric variables into SPSS, we have to figure out how we're going to code the data. Let's say that we have a sample of 50 people. We want to know how many are male and female. We can't simply enter male and female and expect SPSS to understand it. We would select some numbers. We could code 1 as male, 2 as female, or vice versa. Let's say we wanted to know or have SPSS generate the number and percent of races represented in our sample. We might code 1 African American, 2 for Asian American, 3 white, 4 Hispanic, and so on. Developing a code book is very important. It's also helpful if you have more than one person assisting you with your study. They can pick up the code book and understand exactly how you have coded the data in SPSS. This is a sample code book from the Healthy Schools, Healthy Families, Healthy Kids data set that you will be working with throughout the semester. In the first column, we have the variable that we collected. In the second column, we have assigned the type of measurement scale that's associated with that variable. Again, SPSS will ask you for this information. The third column is the type of variable. The fourth column tells us how the variable will be displayed or interpreted. We've already said that categorical data can only be displayed as number and percent, also known as mode. But continuous variables can be displayed as mean, standard deviation, and range. In the last column, we're letting ourselves or reminding ourselves or anyone else who looks at the data set how we actually coded the data in numeric form. SPSS can't average words, but it can average numbers. Once we've completed our code book, we can use that information to enter the variables into SPSS. This is a screenshot of the variable view in SPSS after taking the information from our code book to set it up. Using that information in the code book, the variables have been identified. This column tells us the integers that will be needed to represent the data, and if there are decimal points needed. Label is simply a longer explanation of the name of the variable. When SPSS is run and you develop some output tables, it will only give you these abbreviated names of the variables. So you can look at your code book, or you can go to this view in SPSS to help you understand what BMI1 really means. If you have a categorical variable, you will need to tell SPSS how it's coded. So notice, for everything that has been labeled ordinal or nominal, we have an explanation as to how it's coded. Scale is the same as interval ratio level data, so we don't have to really explain that. The numbers will represent themselves. Later on this semester, you will develop a mock-up code book and use it to build an SPSS data file.